Okay, so we are continuing now the Rambam of orech reviiB. Now, there's a lot of mathematics involved in how to figure this out. Again, the point of this is we were up to yesterday to this picture here, is take a look at this triangle here, ABC, and let's assume it's a spherical triangle, and CB is the horizon, and AC is the tele, is from A to C, that's below the horizon. And we want to know what is AB. That's the degrees of the celestial equator. This is what we need to solve in the mathematical thing. We need to solve that when AC is below the horizon, let's say 30 degrees, the full tele has set. What will be AB? That's the circle, the great circle of the celestial equator. Again, if you don't have a spherical celestial sphere, what I'm talking to you is almost going to be like you wouldn't have what's happening. So, as I said yesterday, get yourself a celestial sphere, a celestial globe, or you can just, as I said, make it on your own with a cup, with a glass. You take a tiny 99 cents globe, you make up your mind that the equator is really the celestial equator, and you put that on a glass that exactly half of that globe goes inside. And make sure the celestial equator is 58 degrees towards the rim of the glass. That will represent that in Eretz Yisrael, the celestial equator is 58 degrees towards the horizon. And then also, before you put in the glass, make a magic marker 23.5 degrees circle that should be inclined towards the celestial equator, and that will represent the Galgal Amazonas. They will meet at 2 points, where the magic marker circle, where the equator circle meet, will be Tele and Meznaim. Now, when you put this into your glass, and half of the globe is inside the glass, so you start turning it, and try to turn. Make sure when you turn, you always make sure that the equator is 58 degrees towards the rim of the glass. That means because no matter what happens, always the celestial equator is 58 degrees towards the horizon. But you will realize that there is, after the part of the celestial equator sets, it's underneath it's underneath the rim of the glass. It's basically inside the glass, we can say. Also, part of the ecliptic is inside the glass. So what we need to find out. So you can ask the question in two ways, and it's interesting that is mathematically one way is much easier to solve than the other. In the first way, how the Rishonim asked it was, if we have 30 degrees of the ecliptic setting, how many degrees of the celestial equator are setting? So we have X amount of degrees of the ecliptic, let's say 30 degrees. How many degrees of the celestial equator are setting in this time? The answer is about 35 degrees. That means that by Tele, from 0 to 30, it takes it takes more than 120 minutes. 30 times 4. It's 35 times 4. That's 140 minutes. So, this is one way. You can solve it mathematically, but it's complicated. It's just how the way the triangles are configured, that in this math, that in the way of asking it, that we are given. Take a look at this picture. We are given. Yes, the way that I'm saying right now, we have here the big A and the big C and the big B, and you always know that the small a is opposite the big A, the small c is opposite the big C, the small b is opposite the big B. That's the convention. So in this case, what are we given? We're given small b, because small b, this is the represents the mazalas. Mazalas are set 30. 30 degrees mazalas are set. We are given small b, we're given big A. Big A is 23.5 degrees. This is ecliptic. I'm sorry, this is ecliptic, and this is the celestial equator. Also, we're given this one here, big B, because big B is the angle of the horizon and the celestial equator, and as well as 58. So this is 58, 23.5, and this is 30, because we're given that Taleh has set. What we want to find out is this one here, small c. How many minutes did this take, or how many degrees of celestial equator has set during this period? So we have to solve for small c. Now, interestingly enough, it's complicated. We know a rule by any spherical triangle. If you know 3 out of the 6, this is the iron rule. If you study spherical trigonometry, if you know 3 angles out of the 6, you know everything else. So we have 3 angles here. We know. Yes, we know big B, big A, and small b. We want to find out small c. It's complicated, and I'm not going to go. You can read my book. I'm just going to skim it through. It's really windy method. I found it in a spherical trigonometry book, how to do this if these angles are known. It's a whole drasha. I'm skipping it through. If you want to, you can always email me at weeklygillion or write a comment, and then I can send you the book, and if you're interested. I'm showing here, this is the best I can show for people that don't want to take the effort and get a glow. So I took a grapefruit, and the center rubber band here represents this represents um, this represents the celestial equator. I'm sorry, the horizon. The horizon. Now, this rubber band here, it's very steep angle. This is the ecliptic, the Galgal Amazonas. This rubber band here is the celestial equator. You see here that it's 58 degrees towards the horizon. That's how it is always. So here we see that the celestial equator, now the full, let's make the question in such a way that we have here Taleh has set, 30 degrees of Taleh have set. We know this is 30. We would like to find out what is this here. What angle is this? It means how many degrees of the celestial equator had set during the period that Taleh had set. From beginning of Taleh to the end of Taleh, how many degrees did this? Yes, we start Taleh, both started off at the horizon, and then 30 degrees from 0 to 30 until they have set. How many degrees of celestial equator have set? From 0 till something, till 35. That's the answer. So this is the way of asking. We are given the mazalas. We say that from point 37 till 47 of the mazalas have set. We want to know from what point to what point of the celestial equator had set. Because at any given moment, when there is on the horizon a point on the ecliptic and also a point of the celestial equator. So we can say that we have at a given moment, we have a point on the ecliptic, let's say 50, and then a certain time passes, we have 60. So we can say in this period, what point, when it started by 50, what point of the celestial equator was on the horizon. And then as time passed, now we have 60 of the ecliptic, what point of the celestial equator is on the horizon. So it's other numbers. They're not so far apart, but there is some difference. So this is the mathematics behind this, to find out a certain portion of the Mazalis are setting, and at the same time a different portion of the celestial equator is setting. This is another diagram that shows how it is by Moiznaim. Again, this is the celestial equator. As you see, this is always 58 degrees towards the horizon. However, this represents Moiznaim. After a while, first Moiznaim was on the horizon, then Moiznaim set, and at the same time, Paracelestial equator set. So here, in this case, it's the other extreme, that we have a big portion of the ecliptic setting, while a small portion of celestial equator. So Maznaim has set totally, and at the same time, only 27 or 28 degrees of the celestial equator has set. So that means that it's fast. It goes very. Maznaim sets fast, faster than the average. The average of 30 degrees should be 120 minutes. This takes only 100 minutes to set. This is the other extreme than Tele, Maznaim. How much it takes for Maznaim to set. This is just the same picture again. We have the horizon. This is the Mazalis. This is the Majve. And this is obviously for when Tele. This is Tele. And as I said, it takes a while for this to set. This is the opposite picture. This is for Maznaim. Maznaim is setting here. And there's a certain way how to do it mathematically. And again, we're not going to discuss it here. This goes through again the formula, different ways. Okay. Okay, now there's a totally different method that Baruch Hashem I developed much later. It's not using this complicated method, but it's much, much easier to solve. And this method works the other way around. So we are given this. We are given B, the time, or as you say this, the amount of degrees of celestial equator is given, and we're finding out the mazalas, vice versa. So I'm telling you, we start off with a piece of the celestial equator from 0 to 30. So sketch for Tele totally set is wrong. It should be sketch for 0 to 30 totally set. That's what should be the right thing here. For 0 oh my goodness, it erased. Well, okay, I'm gonna write it. For 0 okay, this is what we need to do here. It's